Right, okay. So, welcome to this lecture. I'm going to talk about, my name is Dimos, I'm going to talk about multimodal communication between humans and machines. It's a bit of the topic of my PhD as well, which I do here at KTH. So basically I'm doing multimodal communication and human-robot interaction, and I'm supervised by Joachim Gustafsson and Gabriel Skanze. Maybe you're not familiar with what multimodal communication is and why does it even matter. So it is in principle the study of interaction through natural means of communication. So these, for instance, could be some pragmatic communication acts that we do when we talk to each other and do conversations. There could be conversational turn taking, for instance, when we exchange turns to speak, and facial expression of affects and affecting emotions. And it also has this information structure and emphasis. But you might tell me now, but Dimos, I'm not doing any multimodal stuff that you're describing. I'm just speaking to people. So, well, you very likely are using a lot of non-verbal cues when you speak. But in some cases, like this, for instance, an everyday scenario, you might not use any verbal signals at all. So you might only use non-verbal signals to indicate some intention to the driver, and equally the driver gets your eye contact, and then you kind of have a joint action. You know what's going to happen. So what is interesting to take away from here is that non-verbal cues in human conversations are situated and contextual. So they involve a lot of information about what is happening in this environment. So these non-verbal channels. So of course, if I'm talking about multimodal communication. So if it was different modalities being involved, many of them would be eye gaze or iconic and communicative gestures, etc. And spoken intonation, body posture. So now this is interesting. So how can we make use of that information, which carries a lot of context and situation awareness in multimodal interfaces? So how can we make machines being able to recognize these cues? So let's assume that you were a robot or a computer system getting this as an input, and you should be able to, given that input, make some sense on the world, what is happening around you. Could you make something out of this? Any ideas? Well, you say it's quite obvious, Dimos. There's probably some relation between those entities that you just read. Maybe you didn't understand my question, but that's my fault. But right, so basically you can see that there's a bit of there's an object here, and there's a subject, and there's some information between them. So you can tell there's an object of interest that the robot or the computer should try to make sense of something. So this you could do by just parsing this text but still it's still missing a lot of information. So perhaps you could try and put some other modalities, like spoken intonation, for example, and see if we can get more information about the environment.
There is too much butter on those trays.
Right, so there's definitely an emphasis here. So those trays must be something important and something that the speaker has emphasized that needs to be done with. But we're still missing a lot of information. So where are these trays? Am I holding these trays? Are you holding these trays, or are they somewhere on the room? So now we could add more modalities, like for instance eye contact and pointing gestures, to see if we can get even more information. Well, there's going to be even more, but let's see how it looks like.
Okay. There is too much butter on those trays.
No, senor.
What?
Not on those trays. No, sir. Uno, dos, tres.
Okay, so well, the speaker is indicating his intentions very clearly. So he pointed and looked at the trays that he talked about. So of course there's more information there. There's some objects and some actors that are involved in that situation. So now the idea is that if we had a multimodal interface that can take use of these actions, could it understand what's the context of human conversations? So basically, a multimodal interface is a computer interface that intends to converse with a human and with a coherent structure. And it could employ speech and haptics and gestures and other information from humans to understand what is happening. So we had some cases from 1979, one of the first multimodal interfaces at MIT.
Create a blue diamond there. Move that there. Put that there.
So this is very impressive for 1979. So it's basically an interface that is able to take more cues than traditional user input into account and try to create some more coherent interactions. But now we still haven't used both channels of this multimodal communication. So far we're using the human input without necessarily generating a multimodal output, which is where robots make a lot of sense. So we have plenty of robots that tend to look like humans and employ many of these human-like features on their designs, or maybe some of them, depending on the scenario that we're working on. So basically, social robots are in principle multimodal interfaces, but they're embodied interfaces that they have also the ability to generate these multimodal cues to humans. And they do that in two ways. Of course, they use verbal and non-verbal cues, as we described before, and they're basically encourage users to anticipate that there's a joint action in this environment. So basically, now we know that non-verbal cues are situated and that they actually give a lot of information about the grounding of what's happening in the physical world. And social robots are making use of these cues to enable social facilitations with the users. And sometimes they also have some more anthropomorphic designs, like we saw on the first robot that had a human face, which is a very common metaphor in the domain of computing. And
Nice.
Thank you.
Add 5 pieces of lettuce to your spring roll.
so sometimes they don't have any anthropomorphic designs, like a smart speaker in that case.
1, 2, 3, 4.
So this is research we did here at KTH. And we
Right.
wanted to see, well, is there any social facilitation between these?
Perfect. Next, take the correct amount of red
Well, that's
cabbage and put it in the
subjective and
spring
maybe up
roll.
to you to decide, but very little you
red
would say. So
cabbage,
there's not a lot of eye gaze.
How
for
much
instance.
is the correct
There's
amount?
not a lot of information at
I recommend you to add 3
the
pieces
speaker,
of
at the
red
interface
cabbage.
to look at it. So what would happen if we had an interface that now would have a human-like face and some non-verbal social cues involved in this interaction? Would it change it?
Perfect. Add 3 pieces of yellow pepper to your spring roll.
Yellow pepper. One.
So what we saw
That's
here
quite
was
a
that
lot.
they were actually asking a lot of
Yes.
questions and
Like
pointing to the
yellow
robots
pepper.
and asking questions like, is it this one you're talking about,
that
or
was
is that one,
great.
etc.
Thank you.
So just by using a
Next,
human face or a
Take the
human-like
red
face
pepper and add it.
Three
so this kind
pieces?
of anthropomorphic design, users
Yes.
basically change their behavior. They expect that the robot knows what is happening on the environment. So what we know now is that anthropomorphic agents are in principle more sophisticated by what humans perceive, and they also make use of these nice social cues. So basically, what they do is that they ascribe these human-like features in otherwise non-human objects, so machines, and they provide this form of illusion that the users think that actually something sophisticated is in this machine more than just a simple understanding of what's happening in the scene. So, right. So going back to what I said before, multimodal cues are important in this context, in this type of interactions with machines and social robots. But it's also important that they come in the right quality, intensity, and timing, and that they reflect the signals that the humans have sent. So, how we do that in the field of HRI is that we have an agent that is taking some action and then has an expectation to that action as a reaction from the humans, and that you could form as a correlation between any robot behavior and any changes in the environment. And doing that, we're able to establish the social facilitation between users and humans and machines, and create a neural sense of grounding. Thanks.